Scientists use both estimates and physical measurements when conducting research. An estimate is an approximation of a number based on logical reasoning, assumptions, and observations. For example, you know that standard school fundraiser of guess how much candy is in the jar? Well, your guess is the estimate. It's how many you think may be in the jar. In order to find the actual measurement, you'd have to dump all the beans out onto the table. And the true measurement would be obtained by counting all of the beans at one time. Can we say hashtag time consuming? All right, let's take a look at a couple of real life scientific examples. Okay, so what I'm going to show you here is an ant colony. I'm going to lift up this rock and I'm going to try really hard not to get bit by any of these ants. And you can see the colony underneath the rock. And the ants are moving around everywhere. It makes it very difficult to count exactly how many ants are in the colony. So I'm going to show you a different way to do it based on estimation. Estimation is based on logic. So how do we estimate the number of ants that we can see in this picture over here, which is a picture of part of the ant colony? Well, the first thing we need to do, and what scientists do, is to create a grid over that part of the ant colony with equal sized squares. Then we can count the number of squares over the colony. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now these aren't full squares. They're 2/3 of a square each. So 2/3 plus 2/3, that would be 4/3. So that's 1 1/3. And that gives us a total of 9.33 squares. Now, the next thing we would do is pick one of the squares and count the number of ants inside that square. We're going to use this square here. So we sit down and we count all the little ants that you can see here. Little bitty ants. Anyway, we count the ants and we come up with 14 ants in that square. Now, to estimate the total number of ants in this section of the colony, we take 14, multiply it by 9.33, and we get a count of approximately 131 ants in the section of the colony we are viewing. Again, this is an estimate. We didn't sit down and count every single little ant because, quite frankly, that would be darn near impossible. So what we did is give it our best estimate based on the number of ants that we can count in a certain location. All right, let's take a look at another example. The white-tailed buck that you can see in this short video was captured on one of our game cameras back in December of 2017. Now I've got the video set on loop so you can see this. We want to know the size of this deer, and we can actually estimate it based on specific measurements from trees that he is currently walking past and where he stops. So let me show you how we're going to do this. To estimate the size of the deer in the video, the first thing I did was take a still shot, which you can see right here, from the video. And I chose this particular still shot because the deer walked so closely past this tree right here. So I needed a fixed point. That's why I chose this particular tree. I went out to the woods and measured the height of the tree at a specific spot, namely right here, where the deer walked past. The measurement I got at that spot was 5 feet 2 inches off the ground. Then what I'm going to do is take that fixed point and mark it off in even gradients. In this case, because the spot was 5 feet 2 inches off the ground, I marked off the gradients in 1 foot increments. So 0 being the base of the tree and 5 feet being the point that I measured to, which was 5 feet 2 inches. So from this, I can estimate that the deer has a rack height or antler height of approximately 5 feet off the ground. And I can estimate his shoulder height, which is right here, at approximately 3.4 feet, which is really on the high end of average for a male white-tailed deer. Now, it's important to note the only way to know if my estimates are accurate is to physically measure the deer itself, which is very dangerous and should only really be done by professionals. Okay? So you're going to notice this word I used here, which is accurate. Well, let's move on and talk about accuracy and precision. Accuracy is how close a measurement is to the true value of something. Precision is how close together your measurements are. Let me show you an example. You picked up a stick out in the yard and you want to know the length of that stick. So you get your ruler out and you take the measurement. You measure the length of the stick at 14.7 centimeters. To make sure you measured right, you measure the stick 2 more times and get 14.7 centimeters both times. So then you hand your stick over to your friend and say, hey, double check my measurements for me. Friend says, okay. So your friend measures the stick. Same ruler, same stick, and your friend gets 14.1 centimeters. So your friend says, well, I only got 14.1. Let me measure it again. So your friend also double checks their measurements and gets 14.1 centimeters 2 more times. So who was actually accurate? Well, when it comes right down to it, guys, if you take a look here, you can see that you were both accurate and precise. This is why. You started out by actually lining up the 0 part of the ruler with the bottom of the stick, like you're supposed to. Your friend, on the other hand, lined up the bottom of the ruler with the stick. And you see this gap right here? That's what threw off his measurements. So your measurements were both accurate and precise. They were accurate because they're very close to the true measurement of the length of the stick. They're precise because they're close together. You got 14.7 3 times. Your friend, on the other hand, well, because they used their ruler incorrectly, their measurements were precise, meaning their measurements were close together. They got 14.1 3 times. However, they were not accurate because they used the ruler incorrectly. Here's another example, only this time we're going to use a dartboard. Now, the goal in darts is to get the highest score possible by getting your darts as close to the bullseye as possible. The bullseye is the center part of the dartboard. So we have 3 players here. Player 1 is yellow, player 2 is blue, and player 3 is green. Let's see who is the most accurate. And the first person to throw is going to be player 1. And he throws all 3 of his darts, and we can see they're pretty darn close to the bullseye. Player 2 throws next, and his darts are grouped together, but they're much farther away from the bullseye. And player 3 apparently has no aiming capabilities whatsoever because his darts are all over the place. So let's analyze this. Player 1 was both accurate and precise. He was accurate because all three of his darts landed very close to the bullseye, and he's precise because all three of the dots are very close together. Player 2, on the other hand, was precise but not accurate. He's got the precision down. All three of his darts landed very close together, but they're not accurate because they're so far away from the bullseye. And, well, player 3, he was neither accurate nor precise. His darts are way far apart from each other. There's no precision there, and he's not accurate because he's nowhere near the bullseye. All right, time for you to practice what you have learned. Go to the website listed in the description below, select Math and Science Lesson 8, then complete the worksheet titled Estimation, Accuracy, Precision, and then complete one of the two activities from the Estimation Activities worksheet. Or you could do both. You can learn a lot from the second one especially. Yes, it takes a little bit longer, but it's totally worth it. Well, goodbye for now. Hope y'all learned something today.